Welcome, ladies and gentlemen. May I have your attention, please? Thank you. Let's go ahead and get started with our graphing sine waves. We're going to have to start with a graph of a given sine wave and develop its function based on the different appearances in the graph, amplitude, period, center line, etc. And you're going to have to be given an equation, like in number 2, and generate its graph by your hand without a calculator on the test next class period. So let's go ahead and get started. For the first one, right, we can consider my window here and determine what we're working with. It looks like if my window is negative 360 to 720, we must be dealing with degrees. So what I like to do is go ahead and draw in my center line. I know that in relation to my center line, I can choose key things like, is it going to be a sine parent versus a cosine parent? Because at the y-intercept or initial value, it starts at a max and min, or it starts at an intercept of the center line. And so I want to get that center line drawn in first. So we're looking for that horizontal line that divides the sine wave into top and bottom equal halves. So it looks like right about there. Is that what you guys are doing? Right about there. It looks like that center line then appears to be about -1. So the equation of my center line looks like it's y equals -1. My amplitude I can gain by counting the distance my maximums are from the center line, or the distance my minimums are up to the center line. And so I can go ahead and count out the number of units that separates the maximum value, right, the top of those peaks down to the center line, and that looks like it's about 2 units. And so it looks like I'm dealing with an amplitude of 2, a center line of -1, and the next thing I'll need is the period. So let's go ahead and go from key point to key point, keeping in mind that my window here is going to drive the process. If my x-min is -360 degrees, and I have 1, 2, 3, 4 tick marks on my scale there in the negative direction, we must be going by 360 divided by 4. Quarter periods is 90 degrees. So every tick mark here is 90 degrees. So I'm going to see how far it is from this first key point. I'll say an intercept of my center line up to the same key point. One full cycle looks like it took 1, 2 tick marks, so 180 degrees. So my period here looks like 180 degrees. Okay, before we generate the equation, I need to do a quick check. Raise your hand if you had the center line of y equals -1. Did you identify that same center line? Great. Different check. Raise your hand if you had an amplitude of 2. Amplitude of 2, that's good news. And lastly, the trickiest part is period. Raise your hand if you identified 180 degrees for the period. Did you find that, 180 degrees? Excellent. So now we'll use this period to calculate my speed factor. I know my speed factor b, and the final thing I'll need in my equation is given by the normal period of a trig function in degrees, 360, divided by the observed period for this particular function. So 360 divided by the 180 we just saw equals my speed factor b, and that looks like it's 2. This makes sense. If my period is 180 degrees and my normal period is 360, this particular sine wave takes half as long to complete a full cycle, which means it must be spinning twice as fast. That's why my speed factor b, or frequency, is 2. It's twice the frequency of the parent function. All right, moment of truth. Here we go. Is this a sine parent or cosine parent, given that I start at an intercept of the center line on the y-axis? My initial value is the intercept of the center line. So is my parent function a sine or cosine? Joe? Sine. Sine, good. So this is working towards y equals a times sine of bx plus or minus d. For us, we've already identified amplitude of 2. We've calculated a speed factor frequency of 2 also. Uh-oh. Of 2 also. And lastly, my center line, right? Everything was shifted down 1 unit, so we need a -1. Yikes. Striving for PDF-able, we had to have a round 2 in order to get there. Awesome. What questions do you guys have about number 1? Let's do the same thing for number 2 then. Let's go ahead and draw in our center line first. So if we draw in our center line first, it looks like that invisible horizontal line that divides it into equal top and bottom halves. Right about, is that it? 4, 1, 2, 3, 4. So you guys getting out there? Y equals 3? So center line of y equals 3. Raise your hand if you have y equals 3 for the center line for this one. Anybody else have that? Y equals 3? Awesome. Okay, now let's go ahead and consider the amplitude. That's the distance that connects minimum back up to the center line or maximum down. Because I'm right here on the y-axis and can see this is a minimum, and I have a scale, I'm going to count here. 1, 2, 3, 4. So it looks like 4, an amplitude of 4. So my amplitude appears to be 4 units. Does that work here? 1, 2, 3, 4. Yep, that looks like 4 units. Good. And then my period, that's the length of time it takes to complete one full cycle. So for my period, I'm going to go ahead and see how long it takes to get back to that same key point. In this case, a minimum. So we're going, and it looks like it takes this full 4 pi units to complete one full cycle. Therefore, my period is 4 pi. The last thing we'll need is my speed factor, b, right? My frequency relative to a parent function. So to calculate that, again, we'll do b equals my normal period, in this case radians, because my x scale is measured with radian x value. So we'll say that's 2 pi divided by my observed period. It's observed a period of 4 pi in this particular function. So we'll reduce that and get my speed factor of, looks like 1/2. That makes sense as well. If this takes 4 pi units to complete a full cycle, and my normal parent function takes 2 pi units, this one takes twice as long to complete a full cycle. It must be spinning half as quickly. So that makes sense. Let's put it all together and see what we have. First, I need to decide, is this a sine or cosine parent, given that I start at a minimum relation to the center line on the y-axis. So is this going to be a sine or a cosine parent? Hans?
It's going to be cosine.
Good. A cosine starts at a max or min in relation to the center line. So I'm working towards the y equals a times cosine of b times x plus or minus my center line. And my a value here, we saw the amplitude of 4. However, I'm starting at a minimum, not a maximum. That's opposite my regular cosine behavior, which normally starts at a maximum. So I'm going to include that with a negative 4 as my a value. Everybody see that? Opposite behavior, negative 4. That's where the negative doesn't affect the amplitude, right? It's still a positive amplitude because that's a distance, but the negative affects the behavior. That's exhibiting the opposite behavior from the cosine function, which starts at a maximum. This one starts at a minimum on the y-axis. The rest we've got, 1/2 is my frequency, so my value of b in my sinusoid equation is 1/2 times x closed angle input, and then after the fact, our center line here, we already saw was up 3, so plus 1, 2, 3. We'll add on after the fact, and then awesome. What questions do you guys have about letter B? Great, let's start at an equation and work our way towards the graph. And so we're going to state the center line, the amplitude, and the period of this sine wave before carefully sketching a graph on our own. And you're going to have to do that on the test on the non-calculator portion. So this is a great test question, right, to practice with. So let's go ahead and state the center line. We can pick out our center line simply by looking at my equation. It looks like that addition or subtraction outside of my parent function is my center line. In this case, it's a positive 1. So I know my center line is y equals positive 1, and I'll go ahead and put that on my graph. Next, we want to go ahead and get the amplitude. And so the amplitude I can gain by taking the absolute value. The absolute value of A. In this case, the absolute value of negative 2, bless you, is positive 2. So the absolute value of A is 2. My amplitude is 2. That's a distance. It's always positive. And lastly, we need the period. The period is gained by taking my normal period in a sine wave is 360 degrees, and dividing it by the speed factor. In this case, my speed factor was 2/3. So I'm going to take 360 degrees, and I'm going to divide it by 2/3. Keep in mind, dividing by 2/3 is the same as multiplying by 3/2. And so it looks to me like 360 divided by 2/3 is the same as 360 times 3/2. 360 divided by 2 is 180 times 3 is what? 180, 360, 540. You guys getting 540? So I'm getting a period of 540 degrees. Raise your hand if you had that for the period. Anybody else have 540 for the period? Hey, good job. In order to make my scale though, right, and to make it easy for my graphing, I want to get not a full period necessarily, but a quarter period. That's what I'm going to use for every tick mark on my x-axis. So I'm going to do a quarter of 540 to figure out how I should label my scale. A quarter period then looks like it'll be 400, 100 plus any other, 140. That doesn't work out very nicely, does it? What's a quarter of 540? 135? 135? Okay, so it looks like 135 is a quarter period. So when I go and make my demarcations on the X scale, I want every tick mark to be 135. Let's try. So here we go. 135 degrees, 270 degrees, 300, 405 degrees, and 540. Oh, that does work out well. No problem. That's why we got a quarter period, right? We know that in 4 tick marks then, we'll hit each of our 4 key points, right? Intercept, max, intercept, min, intercept, max, intercept, min, forever. Let's do the same in the negative direction. Negative 135 degrees, negative 270, negative 405, and negative 540. Great. So is my parent function a sine or cosine? Is this a sine or cosine? Rachel?
Sine.
Sine, thank you. Am I going to start at an intercept of the center line or a maximum/minimum in relation to the center line? Caitlin? Center line. A sine function starts at an intercept of the center line. So I know my key point on the y-axis is right there on the center line. Good, thank you. Now I'm going to go ahead and go, normally I go on my way to a maximum. I count my amplitude units, right? In a quarter period, I'd be up to a maximum. However, there was a negative on my A value here. That means it's exhibiting opposite behavior. Instead of being on my way up to a max, this is going to be on its way down to a min in a quarter period. The amplitude is 2, so I need to count now 2 units, which puts me right there. Another quarter period, back to an intercept. Another quarter period, up to a max. Another quarter period, back to an intercept. And complete the same thing, all right, going in the other direction. So we're center line, max, center line, min, center line. Let's take a minute, bless you, and see if we can't sketch a nice smooth sine wave here. So we've got our down. There we go. Awesome. So everybody see how that has an intercept of the center line on the y-axis. So it's a sine function, but it's opposite behavior, right? That's where the negative sign comes in. It's on its way down to a min as opposed to being on its way up to a maximum. That's what the negative does. Awesome. So raise your hand if you have this picture. Did I make it all the way to this picture? So good, good, awesome. What questions do you guys have about number 2? All right, so we did delineate which topics would appear on the non-calculator portion versus the calculator allowed portion of your test. Again, that's next class. But first, we need to take care of our homework check. So I'm going to pause the recording while we check our answers. Okay, ladies and gentlemen, so your chapter review assignment, right, is included on your printout for today. It's the same thing that's on your purple sheet, day 13 assignment, and this will be collected at the start of next class. That is your test. So next class period is your test. You want to make sure that you're working and preparing. The calculator portion includes law of cosines, SOHCAHTOA questions, right triangle trigonometry, we can use our sine, cosine, and tangent ratios, unit circle conversions, evaluating trig functions, and then the non-calc portion includes knowledge of the unit circle and making the explicit connection between sine and cosine versus the y and x coordinates of any point on the unit circle. Exact values, we give you the little screenshot like we did on the quiz of those triangle ratios, but we could now add degree measure for our angle input or radian measure, and you'd be expected to know that pi over 4 radians corresponds to 45 degrees. You can always do that by thinking about a half circle represents pi radians. So a quarter circle would be pi over 2, and then, right, then an eighth of a circle would be pi over 4, and so on and so forth. And then lastly, graph transformations, just like we did number 2 for Bellwork, okay? While you're working on that, I'm going to come around and I'm going to get your stamp total for Unit 8. And this is the big bad mother daddy of them all. You can see 13 days means 13 red marks possible. Activities, there are 15 stamps total. Day 4, back at our meeting of the sine and cosine, that's our unit circle rotation activity. Out of 4. Our day 7 activity 2 was our radian measure where you did the pipe cleaners. That's out of 6. And then our activity 4, it moves, the transformation one we did last, that's out of 5. I'm going to go ahead and pause the recording now and save it.